So we're talking about separable differential equations. So we have dy over dx. Oh, sorry, let me scoot this down. We have a separable differential equation. So dy over dx is going to equal e to the 3x times e to the 2y. Okay. Now, when dealing with a separable differential equation, the idea behind it is that you want to get everything that has an x onto the side of the problem that has dx, and everything that has a y onto the side of the problem that has dy. Okay? So this normally means that things are being multiplied together. Okay, so you'll have a function of x, like an f of x, and a g of y. So right now, this doesn't necessarily look like we have like an f of x and a g of y, but we can use exponent rules to manipulate this problem. Okay, so we can separate that e. Okay. All right. Now, like I said, we are going to move everything that has a y onto the dy side of the problem, and everything that and then we need to move this dx to the opposite side of the problem. Okay. So if we would multiply both sides of this by e to the minus 2y, we would end up with e to the minus 2y dy is going to equal, now this is going to be e to the 3x dx. Okay. Now, once you have separated them, then what you're going to do, you're going to integrate them. Okay. So then we're going to say we're going to do the integral of e to the minus 2y with respect to y is going to equal the integral of e to the 3x dx. Okay. Now integrating e to the minus 2y, what is this going to do? This is going to turn into e to the minus 2y divided by negative 2, which is going to equal e to the 3x, now divided by 3, and I'm going to say plus c1. I can see there's a question, but I'm recording right now. So let me get through the recording and then I'll answer that question. Okay, so the first thing to do would be multiply both sides of the problem by negative 2. So that's going to end up giving me e to the minus 2y is going to equal negative 2 divided by 3 e to the 3x, and then I'm going to say plus c. Okay? Now, in general, guys, the reason that this turns from a C1 into a C is that you don't want, all right, especially when you get towards the end of these problems, you don't want to have like C1 multiplied by negative 2 because you're just going to get another arbitrary constant. So whenever you manipulate these constants, just start changing their number, because when you get to the end of the problem, you're just looking for an arbitrary C. So you don't want to say I'm looking for negative 2 of the natural log of C1 or something crazy like that. You just want to make it as easy as possible. Okay. Now, if we want an explicit solution to this problem, right now, this would be considered an implicit solution because we haven't solved for y. Okay. In some problems, it is impossible to solve for y. And so that is what's known as an implicit solution. If you can't solve for y, it's implicit. But if you can't solve for y, it's going to be an explicit. Okay. So in this problem, we can solve for y. So the first thing to do would be to take a natural log of both sides of the problem. Okay. So if we took a logarithm of both sides of this problem, we would end up with negative 2y is going to equal the natural log. Okay, this is going to be negative 2 divided by 3 Now this is e to the 3x plus c. Close your parentheses. You're gonna run out of room on this page. Okay. So the final solution to the problem is going to be that y is going to equal the natural log now of -2 divided by 3 e to the 3x plus c, and now divided by -2. Okay. And that will be the explicit solution of our problem.